All right, day 5. Proving triangles congruence. So let's review. We learned about SSS. All three sides congruent on both triangles. We learned about SAS, which was an included angle. We learned about ASA, which was an included side. And we learned about AAS, angle side. And remember, order is very important here. SAS and ASA are not the same thing, even though the letters are the same. Totally different. And remember, there's a very key important thing. I'm going to keep repeating this. There is no ASS, also known as SSA. That is not a rule. You can't do that. Now, one more, and this is the last one, okay? HL. HL is when you have two right triangles. It has to be a right triangle. This is very important. Must be right triangles. This H stands for hypotenuse. Hypotenuse, which is the longest side of a right triangle. This is my H, and it's always opposite the right angle. And then as long as you have one other leg that matches, you then have congruent triangles. Now, if you look at this, I just want you to realize this is one time where ASS actually works, but we don't call it ASS. We call it HL because ASS does not work on every triangle. This is the one circumstance. So if you ever find yourself with ASS, before you say no, make sure it's not a right triangle, because in that case, it most likely will work for HL. All right, writing congruent standard for each pair of triangles. Well, first off, I'm just going to label these. Okay? So we have X, Y, and Z. I want to put, no, I'm not. I will eventually. Try that again. I'll put X here, Y here, and Z here. Now, what does X line up with? X matches up with R. What does Y line up with? S. And that means Q lines up with Z. And we can check that. It does. Now I'm going to mark it. YZ. This is really off today. YZ is congruent to SQ. XZ is congruent to RQ, and XY is congruent to RQ. I'm sorry, RS. All right? So in this case, we could say XYZ is congruent to, now we got to follow along, so highway 3, highway 1, highway 2, XYZ, 3, 1, 2, so 3, 1, 2, RSQ. And we say by SSS. All right, now over here, we have angle A, so let's put that here, is congruent to angle E. And angle C, let's put that here, is congruent to angle F. And then AC is congruent to EF. So we have A congruent to E, C congruent to F, and what do we have? We have side, angle, side. No, we don't. I know my letters. What we have is angle, side, angle. That was just silly. And over here we have angle, side, angle. It all works out. Now, we actually don't have a third letter to make a congruent statement, so let's just call this B, and we'll call this G. So, ABC is congruent to EGF by angle, side, angle. All right, example 1. Are the triangles congruent based on the given information? If so, which postulate is used, and write a congruent statement? So we know PSR is congruent to PQR. So I'm going to write PQR right underneath here. P, that's an R. Try this again. PQR. I'm sorry, that's angle. So angle PSR, which is here, wow. Really off today. PSR, which is here, is congruent to PQR. Now, this is actually one of those ones where we could have just said angle S is congruent to angle Q because it's the only letter there, it's the only angle there. And SRP, now this is one where it is important, is this angle right here is congruent to QRP. And then we also know that this side is always equal to itself. So what do we have here? We have AS. Is that one of our rules? Yes, it is. So we can say triangle SRP. And what did I do? I went from angle 1, angle 2 to the third angle and back. So I'm going to start at angle 1 to angle 2 to the third angle and back. QRP is congruent to triangle QRP by AAS. Okay, example 2. Are the triangles congruent based on the given information? Same thing. Given AB is congruent to DC. So AB is congruent to DC. Angle D is a right angle. Angle B is a right angle. And AC is not given, but we know it's congruent to itself. Well, what is AC? AC is the hypotenuse. And here we have a leg. So, I'm going to say triangle. Now, you can start wherever you want. I'm going to say DAC. That's what's kind of tricky. I'm starting at the right angle, going up to A, and coming down the hypotenuse. And then back. Down 1. So, if I start at B, remember the last word I want to take is 1. I want to go B, C, A. So, congruent to triangle BCA, and by what rule? HL. Example 3. Let's see what we got. Always a good idea to draw two triangles. And let's see what we have. JK is congruent to WI. JO, so that's got to be up here, is congruent to WN. So that's marked. Angle J is congruent to angle W. Well, what we have there is side, angle, side, side, angle, side. And we really don't have a lot of space. I'm going to come down here and write the answer. So for A, I'm going to say that JOK, triangle JOK is congruent to triangle, well, I started at 1, went up highway 2, so I'm going to do WNI. By SAS. Okay, B. Draw my two triangles. I know those don't look alike, but work with me here. MD is congruent to IN. Mark it. ED is congruent to AN. Mark it. D is congruent to N. Well, that's the same thing as the above one, just kind of reflected. So that's SAS, SAS. So for B, I'm going to say the triangle, any order you want, MED is congruent to triangle IAN by, again, SAS. And last but not least, triangle, triangle, GE is congruent to MT. Mark it. EO, so that has to be an O up there, is congruent to TR. So that's congruent to that. And GO is congruent to MR. So what do we have? Side, side, side. And so I'm going to say, for C, triangle GOE is congruent to triangle MRT by SSS. That's it.